Hello everybody. In this short video I'm going to be showing you how to read drawings from an isometric to an orthographic projection, which showing the front, the top, and the right side views. So as we look at this first picture here, we'll notice that we have an isometric shape here, and from this viewpoint right here, that is going to be called the front view. That is why the front view shows the same object right here in the lower left-hand corner. So this is what you would see when you're standing here in the front view looking at the isometric. As we look down from the top, this is the top view. Notice the top view is directly above the front view, and it shows what the object would look like when looking straight down from the top. Bird's eye view. And here we have the right side view. If you were standing off to the right, where the right indicator is here, this is all you would see, is this square, because that's all you would see if you were standing here in the right looking at the object. So this is the way that the views are laid out. It's always going to be in the same position. This never changes no matter what the isometric shape is that you're looking at. It's always going to be front view in the lower left, top view right above that, and then the right side view is directly to the right of the front view, with the isometric being located in the top right corner. So as we take a look at this first example here, we will notice that the front, the top, and the right side are labeled on the isometric view. This shape here is the isometric view. And what we have on the rest of the screen here is the orthographic projection, showing the front view here, the top view right above it, and the right side view to the right of the front. So let's start with the first letter, A. Letter A is located right here where I'm circling. And if we look at just the front view, if I were standing right here in the front looking at this object, letter A would be represented by number 8, showing this slanted surface. And if I were to take my head and poke it over the top, looking straight down on the shape, this here is the top view, which is what I would be seeing. And letter A would be represented by number 15 because it's off to the right. Just because it's sloped down, I would not be able to tell that it's sloped down when I'm looking straight down on it from the top view. In the right side view, if I were standing at the right side of this object looking at it, letter A would be the largest one right in front, and that would be indicated by number 22. Okay? Let's do another example. Let's take letter K, for example. Letter K is located right here in the center. In the front view, letter K would be represented by number 2. And if I were to take my head and poke it over the top looking down, letter K would be located here, this surface here. So number 17 is pointing to surface K. And in the right side view, surface K, if you notice that J sticks out the furthest, then B sticks out just a little bit less, and then K sticks out the least. So if we look at the right side view, the furthest surface out here would be J, the next surface here would be B, and then the third surface here would be K, represented by number 27. Okay, let's choose one more for an example. We'll take letter E. Letter E is right here. It's this triangular shape right in here. And if we're looking at the front of the object, standing over here in the front, letter E would be represented by number 9, which is pointing to the surface of E. In the top view, number 18 would be pointing to the surface of E. And in the right side view, E would be represented by number 24, which is this top portion of the triangle here. 24 is the darkest number. 21 is a lighter shade, which would represent that it is behind the surface of E, not to be confused with E, which is 24. I hope this helps clarify some questions you might have had when looking at an isometric shape and comparing it to an orthographic projection of the front, the top, and the right side view. Thanks for watching.